So get this, right now, as you're watching this, information is zipping from servers, maybe thousands of miles away, straight to your screen. And it's happening at pretty much the speed of light. It feels like magic, right? But how does it actually work? Let's break it down.
I mean, really think about it for a second. You click a link and bam, a whole web page with text, images, videos just appears. It's not like a tiny little book flew across the ocean to your computer. So what is the secret? How is this even possible? And how is it so reliable?
Okay, first things first, we've got to get rid of this idea of the cloud. You know, this fuzzy, magical place up in the sky where data lives. It's not that at all. The internet isn't some abstract concept. It's a real, physical, and absolutely massive global system. It was designed from the ground up for one thing: moving information. So let's start at the beginning, preparing data for travel, from a message into little envelopes. So before your data can go on its big journey, it has to get packed and ready. And it all starts with some pretty clever translation and packaging. You know, every single thing you see on a screen, a photo, a song, even the words I'm saying right now, it all gets broken down into the basic language of computers. And that language is binary. It's just ones and zeros. That's it. A long, long stream of them. And those ones and zeros can be turned into simple physical signals, like a little pulse of light flashing on and off down a fiber optic cable. But here's the thing. Your computer doesn't just send that huge stream of ones and zeros in one go. I mean, imagine if it did. If just one tiny part of it got messed up along the way, the whole file would be useless. So, to make things way more reliable, your device does something genius. It chops that big chunk of data into lots of little pieces. Then it wraps each piece up in something called a packet and slaps an address on each one. The best way to think about a packet is like a tiny digital envelope. Seriously. Inside, you've got a little piece of the data. And on the outside, you've got the really important stuff, the address. It's basically the to and from for the digital mail system. And that to address? Well, that's what we call an IP address. Every single device hooked up to the internet has one. Your phone, your laptop, everything. Think of it like a unique phone number for your device. It's how the network knows exactly where to send all those little envelopes. All right, so our data is chopped up, packaged, and addressed. Now for the fun part, the packet's wild journey. Once those packets are sent, they're released into the wild of the internet. And trust me, their trip is not a nonstop flight. It's much more like a crazy, chaotic, cross-country race where everyone takes a different route.
And who's directing traffic in this crazy race? These things called routers. You can think of them as the internet's traffic cops. A packet arrives at a router, the router takes a quick look at the destination IP address on the envelope, and in a split second, it decides the best way to forward it on its journey.
Now here's what's so cool about this. There is no single set path. All the packets from the same file don't have to travel together. A router might look at packet number 12 and say, hey, the route through London looks super fast right now, go that way. But then the very next packet, number 73, might get sent on a totally different path, maybe through Asia. Each router is making its own smart decision in real time. And, sometimes a packet just gets lost. Poof, gone. But believe it or not, that's totally fine. The system is built for this kind of chaos. Okay, so wait a minute. If all these packets are flying in from all over the world, arriving in a jumbled mess, and some don't even show up, how on earth do we end up with a perfect picture or web page? Well, that brings us to the next step, rebuilding the message. It's time for quality control. So picture this. All the packets have finally arrived at their destination, your computer. But they're all out of order, and some are just plain missing. It's a total mess. Your device can't do anything with this. So what now? It needs a plan, a set of rules to sort this all out. And that set of rules is called TCP, which stands for Transmission Control Protocol. The best way to think about TCP is as the internet's super strict, detail-oriented project manager. Its one and only job is to make sure that the final message is put back together perfectly, no exceptions. So how does our project manager, TCP, pull this off? Well, it's a three-step process. First, it does an inventory check. It looks at all the packets that were supposed to be sent and sees which ones actually made it. Second, it gets to work reordering them, putting the jumbled mess back into the correct sequence. And third, for any packets that got lost along the way, it just sends a quick message back to the source and says, hey, I'm missing packet number 4. Can you send that one again, please? Simple as that.
Okay, so we've talked a lot about the what, the packets and the rules. But what about the where? What is all this data actually traveling through? This brings us to the internet's physical body, the cables, towers, and buildings that make it all happen. Yeah, we use words like wireless and the cloud all the time, but the internet is a surprisingly physical thing. We're talking about real fiber optic cables buried under your city streets. We're talking about enormous cables, sometimes as thick as a garden hose, sprawled across the ocean floor, physically linking continents together. Your Wi-Fi and your cell signal, that's really just the very last little hop to connect you to this gigantic wired network.
And this brings us right back to the cloud. So what is it? Here's the big reveal. The cloud is just someone else's computer. That's it. It's a fancy marketing term for giant warehouse-sized buildings called data centers, and they're just jam-packed with powerful computers or servers. When you save to the cloud, you're physically saving your file on one of those computers.
So when you step back and look at the whole picture, the physical cables, the smart routing, the quality control, you start to realize what an absolute engineering marvel this whole thing is. The secret to why it all works so beautifully is that it's built in layers. Each layer has exactly one job to do, and it doesn't worry about the others. You have the physical layer, the cables and radio waves, that just move signals. It has no idea what it's carrying. Then the routing layer, with routers and IP addresses, just guides the packets. It doesn't care if they all arrive. That's the job of the delivery layer, TCP, which makes sure the message is perfect. And then on top, you can add a security layer to encrypt everything for privacy. Each layer just trusts the others to do their part. It's brilliant. But you know what might be the most impressive part of all of this? No single person, company, or government runs it. There's no CEO of the internet. The only reason it works is because millions of different networks, owned by countless different organizations all over the world, have all agreed to speak the same language and play by the same set of rules. It is one of the biggest collaborations in human history. So when you really think about all those pieces working together, from a pulse of light in a cable at the bottom of the ocean to a protocol on your laptop putting it all back together, you realize it's not magic. It's actually something way, way cooler than magic. It is, without a doubt, one of the most impressive engineering systems humans have ever built. You know, the internet was built on this foundation of open rules and massive collaboration, and it completely changed the world. It really makes you wonder, doesn't it? What's going to be the next system that comes along and changes everything all over again?